Dear students, today we are going to learn parallel circuits. What is meant by a parallel circuit? In a circuit, if one ends of the elements are connected to a common point or common node to a common point and the other ends are connected to another common point so that there are as many parallel paths as the number of elements, then the circuit is called circuit is called parallel circuit. Let us consider a simple resistive circuit. Suppose I am taking three resistances. So as we discussed, one ends of the elements are connected to a common point. Let's consider the starting ends of these three resistances R1, R2, R3 are connected to a common point. Let us take that point as A, and the other ends, so these trailing ends, okay, these trailing ends, the other ends are connected to another common point. So let us take another common point B. So the starting ends are connected to a common point A and the trailing ends are connected to a common point B. Okay, suppose if this combination is connected across a voltage source, a DC voltage source, let us take the voltage source as V volts. Here, due to the connection of supply voltage, a current of I amperes will flow in the circuit. Now, there are as many parallel paths as the number of elements. Here we have taken three elements, and for this current I amperes to flow in the circuit, there are three paths. So from A, the current is divided into three paths and the number of elements are 3. So if the number of paths equal to number of elements, then this type of connection is called as parallel connection. So this is a parallel circuit. Let us take the current flowing through the R1 resistance is I1. The current flowing through the R2 resistance is I2. The current flowing through the R3 resistance is I3. So the total current supplied by the voltage source has three paths through three elements. Okay, this type of connection is known as parallel circuit. Now let us see how to find out the equivalent resistance in a parallel circuit. Equivalent resistance. So let us consider the same case where three resistances R1, R2, R3 are connected in parallel. So So this is R1 resistance, this is R2 resistance, this is R3 resistance. For getting parallel connection, all the one side ends are connected to one common point, other side ends are connected to another common point. So the starting ends are connected to the common point A and the trailing ends are connected to the common point B. Now the AB terminals are connected across a voltage source of V volts. Now the current supplied by the voltage source is I amperes. Now at point A or node A, the current is divided into three paths. I1 in R1 resistance, I2 in R2 resistance, I3 in R3 resistance. Okay. Suppose if we want to replace this entire network, that means this combination of R1 and R3, R1, R2 and R3 by using a single resistance Rp, so that when that equivalent resistance Rp is connected across the same voltage source V, the current should pass through the circuit is still I amperes. Then Rp represents the equivalent resistance of R1, R2 and R3. Now we need to find out the value of Rp. For that, first let us see here the R1, R2 and R3 and the voltage source, all the four are connected across the same nodes A and B. Therefore, the voltage will be same across R1 and R2 and R3 and for the supply voltage V. Now, for this case, the current through R1 resistance is given by I1 equal to V by R1. Similarly, the current through R2 resistance is given by I2 equal to V by R2, and the current through R3 resistance is given by I3 equal to V by R3, and the total current entering at node A is I and leaving currents are I1, I2 and I3. Therefore, the I should be equal to I1 plus I2 plus I3. So which is equal to V by R1 plus V by R2 plus V by R3. This is expression for I from this circuit. Let it be equation 1. Now from the equivalent circuit, we have V equal to I into equivalent resistance Rp. Therefore, I equal to V by Rp. So this is equation 2. So for this circuit to be equivalent of this one, both the current in the both cases the current I should be same for the given voltage of V volts. Therefore, from equation 1 and 2, we will have V by Rp equal to V by R1 plus V by R2 plus V by R3. So taking V common, 1 by R1 plus 1 by R2 plus 1 by R3. On left hand side we will have still V by Rp. So V gets cancelled. So the equivalent resistance will become 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So the equivalent resistance of a parallel combination when three resistances R1, R2 and R3 are connected in parallel is given by 1 by R parallel equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. Suppose if you connect 4 elements, then plus 1 by R4 is going to be added. So 1 by Rp is equal to sigma I equal to 1 to n when n number of resistances are connected in series, in parallel. 1 by Ri. So 1 by Rp equal to sigma I equal to 1 to n. 1 by Ri gives the equivalent resistances when n number of resistors are connected in parallel. So this is the generalized expression. Okay. Now let us see what are the properties of parallel circuit. The first property is when resistors are connected in parallel, the voltage across each resistance will be same. Voltage across individual resistances or each resistances will be same. Whereas current through individual resistances will be different. Individual resistance will be different. The current through individual resistance will be different, and it will be, the current will be current is inversely proportional to resistance, individual resistance. Suppose in a parallel branch, if the resistance is more, then the current will be less. If the resistance is less, then current will be more. And the equivalent resistance is given by the relation 1 by Rp. That means reciprocal of the equivalent resistance is equal to the equivalent resistance reciprocal is equal to the sum of reciprocals of individual resistances. Sigma I equal to 1 to n. 1 by Ri gives the equivalent resistance when connected in parallel, reciprocal of equivalent resistance. So 1 by Rp. Next, the total power delivered by the source is equal to the sum of powers consumed by the individual resistors in the circuit. So these are the characteristics of parallel circuit. In a parallel circuit, the voltage across each resistor will be same, and current through the resistance is different, and the current flowing through each individual resistance is inversely proportional to the magnitude of that resistor, and the equivalent resistance is calculated by using the relation reciprocal of equivalent resistance equal to sum of reciprocals of individual resistances, and the total power delivered by the source will be equal to the sum of powers consumed by the individual resistances. So these are the characteristics of parallel circuit. Thank you.